Now let's discuss the nomenclature of amides. Again, it's a carboxylic acid derivative. We're replacing the OH with simply an NH2. But this is not the only example of an amide. Even the hydrogens on the nitrogen in the amide could actually be replaced by alkyl groups. So this is also another way to think about an amide. This amide has two R groups connected to it. These R groups don't have to be the same, but they could be. So let's talk about naming the more simple amides first, the ones that are just NH2. Again, let's go back to basics here. If this were a 2-carbon alkane, it would be called ethane. However, since it's an amide, we change it to ethenamide. Notice the system here. We're simply replacing the E in ethane with simply amide. So the name of this molecule is ethenamide. You can even use your common names as well. A 2-carbon carboxylic acid would be acetic acid, so naming an amide, we would call this acetamide. We can even name amides that are substituted, for instance, like this example right here. Notice this is a 3-carbon amide. There they are, the carbons, 1, 2, 3. If it were an acid, it would be propanoic acid, but since it's an amide, we call it propanamide. And since we see that our amide has a Br on carbon 2, we would call this 2-bromopropanamide. And again, using the common name here, the common name for this molecule would be alpha-bromopropanamide. What would we do if our amide is connected to a benzene ring? Well, the IUPAC name would simply be benzene carboxamide. The common name would be benzamide. Now, let's look at an example where the hydrogens on the nitrogen are actually replaced by some kind of alkyl group. So notice we have a methyl directly connected to that nitrogen. What we do is, again, start with the carbonyl side. What we have is a 4-carbon chain here. That means the parent name would be butenamide. And what we do to call out that methyl there connected to the nitrogen is we treat it like a substituent, and we say that the substituent is directly connected to the nitrogen, so we would call this out by saying N-methylbutenamide. Notice this is telling us that on the nitrogen there is a methyl, and butenamide is telling us that it's a 4-carbon long amide. To make sure you got this, let's look at another example. What if there were 2 methyls directly connected to the nitrogen? Again, the parent name is butenamide, and we have to call out these 2 methyls as substituents. And since there's 2, we would have to say N, dimethylbutenamide. But what about if the 2 alkyl groups were not the same, as in this example right here? To name this molecule, again, we start with the parent name, butenamide, and we notice the alkyl groups. In this case, we got a methyl, and we also have an ethyl. We need to place these groups into the name, but remember we should follow alphabetical order. The ethyl, E, should come before the methyl, M. So we would say N-ethyl and follow it with N-methyl butenamide. Now, one more thing to mention about the nomenclature of amides. Just like with esters, you can have an amide within a ring. If that's the case, then this molecule is called a lactam. And the nomenclature of lactams is very similar to lactones. So let's name this molecule here. For lactams, we use the 2-aza-one system. So therefore, the name of this molecule would be 2-aza-cyclopentanone. Let's break down where this name is coming from. Again, we have a 5-membered ring. That's the cyclopentane part. Then remember on carbon 1, we technically have a ketone type group. That's the ONE part. And then notice position 2 here is the nitrogen within the ring. That's the 2-aza part. In organic chemistry, aza is another term for nitrogen. So we can interpret that as position 2 has a nitrogen. So again, the name of this molecule is simply 2-aza-cyclopentanone. You can even use the common naming system here. For instance, the common name for this would be gamma butyrolactam. Where does this name come from? Well, the butyl part comes from the fact that there are 4 carbons within the ring. And of course, the lactam part comes from the fact that the molecule is a lactam. And where does the gamma come from right here in the title? Well, it's just like the lactone. But in this example, we're calling out the carbon that the nitrogen is also connected to. The nitrogen is definitely connected to the carbonyl carbon to the upper left, but it's also connected down below to the gamma carbon within the ring. Hence the name gamma butyrolactam. So this is how we name amides.